Welcome back, everybody. In this video tutorial, I'm going to talk about the composition of functions. It's another way of combining two functions. If you haven't watched my previous video about combination of functions, I suggest that you do that before watching this one. So another way of combining two functions is to form the composition with the other. And this composition is denoted as f of g of x, or g of f of x. This circle does not mean times. This is not the product of f and g or g and f. This circle means that you're putting the function g of x into the function f of x, and vice versa with g of f of x. You're taking f of x and plugging it into the function g of x. Now this may sound a little bit confusing, but we're just going to jump right ahead and do this example in front of us. And I'll leave this here as a reference. You can look at it at any time during this video. So let's go ahead and do the first example. We have f of x is equal to x plus 2, and g of x is equal to 4 minus x squared. So for the first part of the problem, we have f of g of x. So what you're doing here is taking g of x, the whole function, and plugging it in for x of the function f of x. So 4 minus x squared, and for x plus 2. Now it's just simple algebra here. If you break down the parentheses, you're going to get 4 minus x squared plus 2. And that's just going to give you negative x squared plus 6. So for our next part of the problem, we have g of f of x. By the way, this is not pronounced as goff. I've heard this before, and this is a completely big mistake. And this is not pronounced as fog. This is just f of g of x. And similarly, this is g of f of x. Now taking the function f of x, plugging it in for x in the function g of x, is going to give us 4 minus f of x, which is x plus 2 squared. You can go ahead and do the algebra here. We have 4, and we can expand what's in the parentheses. That's going to give us x squared plus 4x plus 4. Then we can go ahead and distribute the negative sign over all the terms within the parentheses. That's going to yield 4 minus x squared minus 4x minus 4. And if you go ahead and group like terms, we just have negative x squared in the front. We have negative 4x, and 4 minus 4 is just 0, so we don't have to write that at all. And this is the answer for the second part of the problem. For the third part of the problem, I'm just going to go ahead and, actually I can just do this here. We have g of f of x with a value -1. So what you do is you just simply follow these guidelines and then plug in -1 for every x within the expression. So I'll just go ahead and do this again, even though we did it once, just for a quick revision. We have g, so 4 minus x squared, and then plug in the function f of x within the x of g of x. That's going to give us x plus 2 squared. And then we're going to expand what's within the parentheses. It's going to give us 4 minus x squared plus 4x plus 4. And then we're going to use a distributive property, or you can plug in the a -1 in here right away. But I rather just get to the most simplified form and then see what the value is. So 4 minus x squared minus 4x minus 4. And then the 4's are just going to cancel, and then we're left with negative x squared minus 4x. And then let's not forget -1. If we plug in -1, we're going to get -1 squared minus 4 times -1. -1 squared is simply 1, and then we have the negative in the front. This is going to become -1. And then -4 times -1 is just going to give us +4. So -1 plus 4. Eventually, our answer is going to be 3. So that's it for this video. I'm going to do another part for this specific video. More problems of composite functions. So make sure to see that. Please don't forget to like this video and subscribe. This is gonna help grow the channel more. If you have any questions or concerns, please leave a comment in the comment section below, and I'll make sure to get to that. And we'll see you in the next video.